Hi everyone. So welcome to another algorithms mini lecture. So today what we're doing is we're just discussing this particular question. What's the time complexity of this algorithm or the computer program? Is written over here. It has two loops, two while loops, and this is one of the questions from the algorithms Q&A book. So what we're supposed to do is we're supposed to analyze this program and try to find the time complexity of it in asymptotic terms here. The only free variable here is n. So of course, our answer should be in terms of n. J and k are just internal variables here. So it's one of the questions here. So how do we analyze it? So the first thing what we can see is that there are two loops. So what we should do is those two loops are nested. We should just evaluate them independently, and then we can multiply the answer because one loop is running inside the other. So let's start with the outer loop. So for the outer loop, that means we ignore everything inside. We just worry about the outer loop here. It says j is equal to 1, while j is less than n, and it just does a j increment by 1. Therefore, this is a simple loop which takes order n time because this will take n units of time to run. We'll start from 1, go all the way till n. Okay. So let's go to the inner loop. The inner loop has this structure, starts with k is equal to 2 and goes on until k exceeds n. So then that's when it'll break out this while loop and does something with the sum. We don't really need to worry about that because it's just a constant time operation. But it does do this thing to k that becomes k is equal to k star k. So that means k becomes a square of k. And eventually k will become too large and will exceed the k, exceed the n. So then this loop will stop. So we can observe that it's kind of a repeated squaring, goes from 2 to 4 to 16 to 256, etc. So if we write in terms of series, it'll become 2 power 2 power 0, 2 power 2 power 1, 2 power 2 power 2, etc. And that's the pattern we have to observe here. So once we observe this pattern, we see that after k iterations of the loop, it reaches 2 power 2 power k. So the loop will terminate when this 2 power 2 power k exceeds n, which in other words says that when 2 power k, by taking log on both sides, we can say 2 power k exceeds log n. And taking log again, we say when k exceeds log n here. Okay. So the main difficulty here sometimes for people is to be able to identify what is a generalization of this pattern. That this is actually can be written as 2 power 2 power 0, 2 power 2 power 1, 2 power 2 power 2, because we can see that it's some power of 2 that's becoming larger. So that's the pattern we observe. So therefore we say we can see that the inner loop takes log n time. Once we have that, we can simply multiply both the loops and the overall time complexity is n log n. So what's there to summarize here? That when you see two loops, simply analyze the two loops independently. And when you see a complicated math structure of how you are seeing the pattern, then you have to identify the generic pattern, which in this case, we observed it to be like this. So you can write down in general terms what the time will be. So that's all I have. Enjoy. And the book has many such questions, similar, slightly different, etc. I'll try to drop a link in the video so you can look at it after as well. All right. Thanks, guys. Keep learning.